Organic chemistry. It is the bane of many second-year university students' existence, and it is probably the reason you are failing your grade 12 chemistry course right now. And while it is widely considered one of the most confusing branches of chemistry, it really isn't that difficult. I know all those confusing lines and angles and such can give your head a bit of a headache. However, don't worry, after watching this video, you will be an expert at naming organic compounds.
So what is an organic compound? Organic compounds come in many different forms and shapes. There are ring-like structures like the one on the screen, and there are line-like structures like the one she's drawing now. But they are all organic compounds. But what makes them organic versus inorganic? Basically, organic compounds are carbon-containing compounds, as carbon is the atom which makes up most of the compounds that are required for life. So how can we best interpret these diagrams? Each bend or point that is shown that is circled is a carbon. Unless otherwise indicated, the remaining bonds of these carbons are hydrogens. So it has 4 bonds, which it is most comfortable with.
Today, we will be focusing on the naming of organic compounds. Yay! Okay, so first things first, when naming an organic compound, you must find the longest chain of carbons. Okay, so starting at the first carbon, we count 1, 2, 3, 4, 5. Okay, that's a pretty respectable number of carbons. So we're going to put 5 at the bottom of the screen. Next, we count 7 carbons, a 7 carbon long chain. That's still pretty good, longer than 5, so it's definitely long. But the next one we count is 10 carbons long. So we're going to put that down at the bottom of the screen, and that's definitely the largest out of all of them. Next one we count is going to be 9 carbons long. Still pretty long, but not as long as 10. And so what we're left with is a carbon chain that is 10 carbons long.
Because the carbon chain is 10 carbons long, we can give it the prefix dec.
Okay, now as you can see, we have labeled each carbon 1 through 10 on our longest chain. And now we have 3 slightly shorter chains coming off of it. These are what we call substituents. Now looking at our 3 substituents coming off the main chain, we can identify them as ethyl, methyl, and propyl.
So we don't have to worry right now about how to name these substituents using their prefixes, but we will get to that later on.
Now that we have identified what the 3 substituents are, it is also important to properly number them correctly. Now, the main chain, the way we should number the main chain is that the substituent is always at the lowest number carbon. So now if we look at our long main chain carbons, we can see where substituents are coming off of it. As we can see, we have an ethyl group coming off carbon number 3, a propyl group coming off of carbon number 4, and a methyl group coming off carbon number 7. Okay, so at the bottom of the screen, we can clearly see that this organic compound name is 3-ethyl, 7-methyl, 4-propyl decane. Now, the reason it is in this order is that when naming substituents in the organic compound, we must go in alphabetical order.
So why do we have all these crazy rules for naming? It makes it so that you know exactly what compound you're using. And with these rules, you'll be able to name anything you'd like.
So whether or not you are naming the carbons in the main chain or in the number of substituents you have, there are specific prefixes given that correlate to the number of carbons you have.
Here are some of the most commonly used ones.
However, when we start getting to the much more complicated types of organic compounds, you may have more than one methyl group or ethyl group attached to your main chain. So if you have more than one of the same substituent, you have to start additionally using prefixes such as di, tri, tetra, etc.
At the bottom of the screen, you can see a quick review on how to name any organic compound.
But wait, there's more? Oh yes, there is definitely more. Organic chemistry is definitely not this simple. In organic chemistry, functional groups are specific groups of atoms or bonds within molecules that are responsible for the characteristics, chemical reactions of these molecules. So starting off with the most basic of the basic, we have alkanes. Alkanes are single bonded carbons that only contain carbons and hydrogens. Next, we have alkenes, which means we have one or more double bonds. Now, alkenes take priority over alkanes. What that means is even if there is only one double bond in this entire molecule, it still takes precedence over the other single bonds, which means that the suffix of this compound is going to be -ene. And finally, we have the alkyne functional group. What the alkyne signifies is that there are one or more triple bonds.
A compound containing this functional group will take the suffix "-ine". So our first oxygen-containing functional group is an alcohol, and the alcohol is characterized by the hydroxyl group, which consists of OH. So the suffix for alcohols is OL or -ol. The next functional group are ethers, which consists of an O singly bonded to two carbons on either side of it. It can either be named by splitting the compound at the O and naming each side, and then putting ether, or naming the smaller half with the suffix -oxy and naming the rest as an alkyl group. Next, we have aldehydes. Aldehydes are characterized by a doubly bonded O at the end of the chain. There is also hydrogen present, but it's not drawn. Aldehydes are named with the suffix -al or -al, and it never has any numbers as the functional group is always at the end of the chain. Ketones are very similar to aldehydes. They have a doubly bonded O somewhere in the chain. They are named with the suffix -one and are numbered depending on where the ketone occurs. Next, there are carboxylic acids. They consist of a doubly bonded O and a hydroxyl group at the end of the chain. They are named with the ending oic acid. Esters are the last of the oxygen-containing functional groups. They are kind of like ketones and ethers put together. They are named so that the doubly bonded O is part of the main chain, and they have the ending O8. The first of the nitrogen-containing functional groups are amines. Amines are characterized by a nitrogen attached to a carbon. Note that there is a hydrogen bonded to the nitrogen that isn't drawn. N is used to denote substituents as a replacement for the number that are bonded to the nitrogen. The main chain must contain only carbons, but there must be a carbon in the chain that is bonded to the nitrogen. The ending for this functional group is amine. Our last functional group are amides. Amides are formed from carboxylic acid and amines and contain an amine group and a doubly bonded oxygen. They are named with the suffix amide. Here are a few things that are important to note. First, that the functional group denotes where the first carbon will be. Second, that the main chain must remain unbroken. And last, that the last suffix is of the highest priority. Here is the order of priority for your reference. All of the functional groups that we talked about today can be combined in a compound in a multitude of ways. It is important to remember the system priority so you can name a compound properly.